And then what I'm going to do is present or project to your screen. And I want to make sure I've got everything set up. Okay. All right. And excuse me, I want to start by projecting this screen right here. So I'm assuming you are now, let me check with that myself, see if I can tell what y'all are seeing. Are you seeing a white screen that says Standards for Dimensioning Architectural Drawings? Is that what you're saying? Good. All right. So in architectural dimensioning, similar to the way things are done in the mechanical world, there's a designer. A lot of times it's an architect. Maybe it may just be a designer, somebody who isn't a licensed architect. And they are coming up with the designs, and in some format, it could be sketches or could be rough CAD drawings, and then they pass those along to the drafters. And the drafters, of course, their job is to try to figure out how to get all the views needed and to follow all the layering guidelines and everything else they have. And so we're going to get into that in just a second. So the important thing is, just like in mechanical, you don't want to make any changes to the design intent of the architect or the designer. So you want to make sure that you faithfully reproduce those dimensions and views and everything else, because just like in mechanical, if you make a mistake and it gets all the way out to the field and they build something incorrectly and then they have to come back and build it differently, it costs a lot of money. And also it's embarrassing to get a phone call from the field on something that you messed up. So I'm going to talk a little bit about that, because it's inevitable. You are going to get a phone call from the field. You're going to mess something up. But anyhow, so let's go on. I'll see if I can get this thing started here. Let's see if I got everybody admitted to the meeting. Let's see. I think Maria. Oh, she got in. Okay, I didn't know if I had to let her into it. All right, so let's talk about this. So, when in mechanical drawing we have this standard called the ASME, the American Society of Mechanical Engineers. Architectural offices have not been that quick to adopt a standard. Most of them have their own standard that they use inside their office. So, and architects are notoriously hard-headed about doing it their way. But recently, what's happened is that there is an architectural drafting and dimensioning standard that is being developed, and it's called the United States National Cad Standard. And let me go back to this thing again. Okay, so let me tell you a little bit about the National Cad Standard. This is a standard that's being developed by architects, construction professionals, people like that, who are trying to standardize some of the way that drawings are done out there in industry. And so, like I said, that architectural firms don't like usually to accept standards that they didn't figure out on their own. So here's how this is being adopted in industry. When a let's say an organization like a school or a hospital puts out bids for someone to design a new hospital or a new school, what they will do in the contract language, and everybody has to sign a contract once you get the award to design the building. What they'll do is they'll put into the contract language that the drawings have to comply with the National Cad Standard. And this is how they're making architectural firms adopt the National Cad Standard. That you don't get paid if your drawings don't comply with the NCS, the National CAD Standard. So this is how it's gaining acceptance in industry. And so for years, architects drew by hand, and they had this beautiful hand lettering, and their drawings were very artistic. And the National CAD Standard is sort of getting away from that, because when you draw with CAD, you have to work a little harder to make your drawings look artistic. And so, like what we do, we like to use that freehand font called Stylus BT. That's one of the fonts that AutoCAD comes in with. And that's the font we have assigned to the guest cottage project. And so that font would probably not comply with the NCS, with the National CAD Standard. Gothic fonts like Arial and Tahoma, things like that, are going to be more common. There's other things that are happening to kind of change the National CAD Standard look. And one of the things is that for a long time, most architects did not use arrowheads on their dimensions. But some of the drawings that I'm seeing, pardon me, that comply with the National CAD Standard actually have arrowheads on their dimensions. And though that's not what we're going to use today on our project, we're going to do more of a traditional look architectural drawing today. So when you see a drawing that was made following the National CAD Standard, it does not look as artistic as they used to look in architectural drawings, but they're very clear and easy to follow, and I think that's probably the advantage. If you want to know more about the National CAD Standard, there is a website, nationalcadstandard.org, and you can go there, and I think the last I looked, they're up to version 6 of the National CAD Standard. And just like with the ASME standard, this is not free, and so you would have to have a credit card if you wanted to buy it. Now, I think if you went out on the internet and searched for the National CAD Standard, you would find a lot of free stuff out there on the internet about the National CAD Standard and about the rules. And one of the places I've found information about the National CAD Standard is that you search for it and you might find some university site, and at the university, maybe they are using the National CAD Standard for all the facilities drawings, and so they have put the National CAD Standard on their site, and it's not password protected or anything. So if you want to read more about the National CAD Standard, you can do that. If you were in a company, if you go to work for someone, the CAD Standard's going to already be, they're going to own the CAD Standard. You're not going to have to pay for it. All right. So another term we need to talk about is Building Information Modeling, which we call BIM. And we mentioned this in Chapter 1, I think, when we were just talking about kind of an introduction. And so BIM is a way of doing drawings where usually you create a 3D model. And in creating that 3D model of your building, you're creating a database. And the database has intelligence. And by that, I mean that, you actually model the ceiling heights at the height they're supposed to be at. And so then you maybe model in your ductwork for your heating and air conditioning in the actual locations where they're supposed to be. And so if you need to know where the ductwork is, or if you need to know the ceiling heights, or you need to know where some structural beams are, you actually go into the model, and you should be able to find those in three-dimensional space. When you do a two-dimensional drawing in AutoCAD, you're not creating an intelligent drawing. It has very little intelligence built into it. You can inquiry on the dimensions and find out what the dimensions are and things like that, but you really don't have a 3D model. And so the advantage of a BIM model is that for the lifespan of that building, you've got this model. So you use the BIM model when you're designing the building. So when you're still working to design it, you can show the client what it looks like in 3D, and they can give you feedback. And then later, when you need to make all your construction documents, your floor plans, your elevations and everything, you're going to print those directly from the BIM model. And so there's not a lot of 2D drafting involved, but there's a lot of 3D modeling involved. Then those drawings that you derive from this 3D model, you're going to send out to your contractors. You're also going to take those drawings down to, let's say, the city of Austin and get your building permits. And of course, this is all what makes drawing so important to the industry, is that it doesn't matter how good an architect is, if they can't have a great set of drawings to take down and get a building permit, they don't get a building permit. So that's what makes drafters and CAD technicians so key in this process. And so if you're really good at doing this, The companies will want to train you up and keep you happy because they don't want you going to a competitor or something like that. So the next part of the BIM model of course, is that all those drawings you created are used in the construction of the building. But after the building is finished and they turn the keys over to the new owner, the owner usually gets a copy of the BIM model themselves. And so, like at ACC, we manage 8 campuses and we have all these different buildings. And so if we need to do a remodel on a building, we have some facilities CAD people. And as we move toward this BIM model, they can open up a BIM model of a new building and they can see where the plumbing is and things like that. If we're getting ready to do a remodel, they know if they tear into a wall, there might be a gas line in there or something like that. With a 2D drawing, they don't know. It's always a surprise. When we tear into a wall at an old campus, we never know what's in that wall. But Highland campus, which our department is going to move to in November, that's the plan anyway, that's all being done as a BIM model. And so we've already been talking about that in our commercial architecture class, in our mechanical, electrical, plumbing class, and some of those classes like that are structural. We may be able to use some of those drawings that actually are from the Highland campus. So if you take classes over there in the future, once we get back to face, we may be able to take the class out into the hall and look at some of the mechanical, electrical, plumbing, and as we explain what's going on there, or look at some of the structural. So I think it's a great opportunity we may have. And so we're going to work with ACC and the architects of Highland Phase 2 to get access to a BIM model. And usually BIM models are done using a software like Revit. And so next semester you can take the Revit course. It's DFTG 2431. And so next semester you could take that if you're interested in BIM. And you could also take DFTG 1417, which is residential architecture. Residential architecture uses Autocad. Now, the reason why we're not using a BIM model in residential architecture is that there still are not a lot of architects using BIM to do residential design. It's BIM design is done more for commercial buildings, skyscraper type, high rise, and commercial things. In the residential world, custom residential, because the sets of plans are fairly small and they really don't need a 3D model because they're not going to manage the house using a 3D model later. A lot of architects are just sticking with AutoCAD. And so right now that's kind of a struggle in the industry. There are a lot of young folks from your generation who are working at these firms and they're saying, even though we're doing residential, this would be a lot easier if we were using Revit instead of AutoCAD. And the older folks in the firm, the owners and stuff, a lot of times they know how to use AutoCAD and they don't want to switch over to Revit, so they're kind of dragging their feet on this. But I think your generation is going to eventually, probably almost all the architectural work is going to be done in BIM. And another thing I'll just say before we move on about that is I've had students get offered a job in industry where the firm used AutoCAD, and they'll come and talk to me and they'll say, hey, I really like this job offer that I have, but the firm uses AutoCAD and not Revit, and I'm afraid that if I work there 10 years, I'm going to be 10 years behind everybody else on Revit. And I think that's a valid concern. And so some students have turned down job offers at companies where they only used AutoCAD because they kind of see the arc of progress is probably going to be toward Revit products or BIM products. All right. So I'm going to keep going here, and I'll speed this thing up here a little bit. So the architectural designers determine where your dimensions and notes are going to go onto a drawing. And so I'm going to show you a piece of a wall, and this is framed using lumber. Okay, so these are like 2x4 studs on this thing. And so we have a opening for a door and an opening for a window, and then every 16 inches there should be a stud depending on if it's 2x4 framing, they'll probably go 16 inches. If it's 2x6 framing, they could probably even go to 24 inches because they've got more structural, strength in a 2x6 versus a 2x4. But the point I want to make about this is this. When we did mechanical drawings, if we had a slot, we would dimension from the one side of the slot to the other side of the slot, and we would have a tolerance on it. In architecture, they don't do it that way. When you dimension to a door, usually what you will do is dimension to the center of the door. And you just tell the framers that's where the center of the door is, and the door is a 3-foot wide door. Same way with windows. Instead of dimensioning to the sides of the window, they will dimension to the center of the window and just tell the architects that's a 3-foot wide window by 5 feet or whatever it's going to be. And I'm going to get into that, but the reason they do that is that the framers generally do something called frame it using a rough opening size. And so let me get my pointer to change the color on it. So here we have a rough opening for a window and a rough opening for a door. And so here's the deal. When the framers are there on site, a lot of times the doors and windows are not there. And every manufacturer makes their doors and windows a little bit different. They may be a little bit different size if it's a pre-hung door and it has a frame built around the door. So what the framers do is they frame this opening for the door usually about 2.5 inches wider than it needs to be. And that gives plenty of room so that when they show up and start putting doors in, that they've got room to fit that door in there. Now they may have to shim around the door and fill it in, but that's why we don't tell the framers exactly how far it is, from one side of our opening to the other. Even if we know that's a 3.0 door, 3.0 meaning 3 feet 0 inches, we don't tell them frame that 36 inches. We just say, here's the center of it, frame it for a 3.0 door. Now, the next slide is going to talk about those rough openings. So let's say that you have a rough opening here for a 3.0 door. That means it's 3 feet 0 inches. We usually use subscript when we put that 0 in there. So look over here in this table. And so here would be a 3.0 door. It would actually measure about 36 inches wide by about 80 inches tall, okay? The framers generally would frame that door opening at 38.5 inches by 82 inches. So you can see they're framing it larger than what they anticipate the actual size of the door to be, which is about 36 by 80. That's what a rough opening is. Now, if you're doing a commercial building and your windows and doors are all set in metal frames and they can be built at a factory and be pretty precise, what I'm telling you may not hold. They may actually be able to dimension from side of a window to the side of a window because it's a lot more accurate than framing with lumber, right? But if we assume they're framing with lumber, what we would do is we would put a dimension to the center of this door, and then we would go to the center of this window, and then we would have our dimension line, and then let's say that that's 10 feet. You would write in here 10, put a foot mark and a dash. Let's say it's 10 feet 4. So we've got 10 feet 4 inches. So we're going to mark the foot mark and the 4, and instead of having an arrowhead right here like we normally would on each end, what we're going to use today are called tick marks, and they're 45-degree lines that go through, and that tells us where the dimensions terminate. Now, like I said, with the National Cad Standard, the National Cad Standard is starting to put arrowheads in, and so you might go to work for somebody and that's what they're using. But we're going to show you the kind of the traditional way to draw these today. And then later on, when you take the commercial class in our department, or you take one of the residential classes, they may use a different dimension setting style. And so all of this stuff that we're doing right here, the way we're setting it up, this is going to be in your dimension style, just like it was in the ASME drawings. Okay, so I have this photo here. This was a little guest cottage that I designed in a town west here called Fredericksburg. And And so real estate goes for a whole lot out there, and they like cute little things. All right. So I've designed this little cottage. And the thing about it, I found this lot that was only 45 feet wide, but it was 180 feet deep. So it's a real weird lot. Most lots are like double that in width. And so what I did is I set this little cottage back 120 feet from the curb. And so the houses around it were sitting like 50 feet from the curb. So it kind of created this little cute little thing setting way back, and it had a bunch of pecan trees and everything. And but I took a picture of this because I wanted to show you guys, as far as framing goes, I have 2 windows here. Well, actually I have 3 windows. And if you look between those windows, you'll see that it took 4 2x4s to frame that. Okay. So I have to, when I draw this thing up, I can't just go in there and say, hey, I want 2 inches between those windows. The framers will call me and say, are you crazy? We can't frame that with 2 inches, you know? And the problem with architecture school, when you go to architecture school, is nobody tells you all this stuff, you know? And so you kind of have to learn this. And so I've had students who've graduated from UT architecture in my 1405 class, and I start talking about rough openings for windows and doors, and they're like, that's interesting. I never heard that at UT architecture, the concept of the rough opening. But in the real world, that's where you hear all this stuff. Just like with mechanical, you hear about tolerances that you didn't hear about at the university. So the reason why you need 4 2x4s is just based on the way that you frame stuff. But here's the thing. I'm going to draw a 2x4. So actually, let me draw it upright like this. So this is the end view of a 2x4 right here. And when we write that, we say 2x4. But if you actually measure a 2x4, what you're going to find is that it's 1.5 inches wide and it's 3.5 inches tall. It's not 2x4. 2x4 is the nominal size of a 2x4. Real 2x4s are going to be a little bit smaller than that. So if I have to have 4 2x4s side by side right here, that means it's 1.5 times 4, and that's going to come out to 6 inches. So as a minimum, I need 6 inches between both of those windows there. And remember, when I dimension this, I'm going to dimension to the centers of those windows anyway. So I'm going to do the math on all that stuff where I've got a rough opening size for that window. I allow for at least 6 inches between my windows. And so something to think about. Now, I want to show you something. Whenever you draw a piece of lumber on one of your drawings and you're showing an end view of a piece of lumber, usually what you'll do is you will draw an X like that. Okay? So if you see a piece of lumber in a drawing, and let's say it's a 2x8, and you see this X on there, what that means is you're looking at the end grain of that piece of lumber. And I remember being in college, and I was in an architecture course, and I was seeing these X's, and I didn't know what the heck those were. And it would have been helpful if somebody had explained that we're looking at the end of a piece of lumber on that. Okay, so that's just a little FYI. Now, I want to show you another way that you can screw up on a job. Okay, so here's the front of that house. I'm actually going to go to the next slide. Let me just go to the next slide. Oh, it's not the next slide. It's just a photo. Okay, so let's say that you walk up to the front of that house, and this has a silver radiant barrier on it, by the way, before it gets the siding and everything. You walk up, and the door handle is going to be on the right-hand side. So the swing is to your left, all right? So the hinges are over here on the left side of that door, and we call that the hinge jamb, J-A-M-B, the hinge jamb, all right? And so when I swing that door open, let's say that it's night, and I swing that door open, and I need to turn the lights on, I would expect the light switches to be right here. As I swing that door open, right? You would expect those to be on your right side. If you put the light switches behind the door, that would be a really bad design, okay? People would hate you for the rest of your life if you did that. So you want to make sure you get that right. So if we look at it from the inside of the house, the door swings in this direction right here. That means our light switches go right there. Okay. Now, probably the first switch as soon as you walk in there is going to be the porch light. And then next to that, there's going to be another switch that may be an overhead light in this living room thing. There may even be a third switch in there that turns on a ceiling fan. So the electrician comes in, and the electrician has to mount an electrical box for each one of those switches. All right. And you've seen these electrical boxes before. The switch mounts in here. It's got a screw on each end of it. And then you put a switch plate over that. But anyway, so imagine you've got a switch, and you have a switch, and you have a switch here. So this one is your porch light. This is your overhead light. This is your ceiling fan. If you don't have enough space between these studs right there, you're going to get a call from the electrician because you're showing 3 switches there. And if there's not enough framing, if there's not enough space in there, they're going to say, hey, you're going to get this nasty phone call. And nothing makes electricians and framers happier than calling the designer and telling them they're an idiot. Okay? It just makes their day. So just beware of that. So you have to think of everything when you're designing, even something simple like a house like this. You've got to imagine yourself walking into that house and turning those switches on. And then you've got to imagine, do I have enough room to even mount that many switches here? Do I have enough space between my windows? It's all kinds of stuff like that. You've really got to use your imagination. And another thing I think is really important in designing is, you think about where would you even put a couch? Where would you put end tables? Or you go into a bedroom, where would the bed go? In poorly designed things, you go into a living room and you don't know where you would put the couch. You won't know where, and most people are going to have a TV, let's say, and a flat screen. Where's that going to go? Think it all through. And that's what makes people a good designer. When I was in school, I had an architect. He was my professor, and he said that he had designed a house one time where maybe he hadn't designed it, but one of the worst designs he had ever seen was that when you open the door to the bathroom, if someone was sitting on the toilet, they could see into the living room. Okay. I always love that as just an image. And the thing is that when you're looking at a 2-dimensional floor plan, it looked like the bathroom was a long way from the living room. But because of the way the hallway and everything was set up, you had that situation where you could see into the living room, or vice versa. People in the living room could see into the bathroom. Now, if I had screwed that up, what I would say is that it was a feature, so that you could go to the bathroom and still continue to watch TV. That would be one way to cover that up. So think up good excuses too if you're going to go into design. All right. So here's an example of actually your capstone project if you decide to do the architectural project. And so we have some dimensions here. And starting at the edge of the framing, we have an extension line right here, and it needs a little gap on it. Then we have a dimension that goes to the center of a 2830 single hung window. So we've got a window over the sink right here. 28 means it's 2 feet 8 inches wide from here to here. Okay, so 2 feet 8 inches, I believe that's 32 inches. When they frame that, they're probably going to frame that 34.5 inches wide. And then the 30 represents how tall that window is, which you would see in the elevation view. You can't see in the floor plan. So we're just telling the framers where the center of that window is, and then from the center of that window over to here to the edge of the framing right here, it's 6 feet 1 1/2 inches. This is 5 feet 10 inches. And then we continue with our dimensions because there's nothing else we want to get in here, and we go 12 feet 0. That's how wide the porch is. All right. Now, there are some windows and a door back here that are, right on this wall that adjoins the porch. And we're actually going to run those dimensions on the inside of the house. So from the framing to the center, we have 2 feet 4. Then we go 3 6. We go 4 2 to the center of the door. And so if you look at this door, you can see where the hinge would be right here. That's the hinge jamb. Where the door closes right here, where your lock would be, that's called the strike jamb. Okay. So we've got the hinge jamb and the strike jamb, and then it says 3.0. That means it's a 3 foot 0 inch door. And right here, you can see there's two S's with a line through it like that. That is a switch that's on that wall. Okay. Now right here, you see this symbol we have right there, that circle with the two lines through it. That is a 120 volt electrical outlet mounted on the wall right there. So it's not actually mounted in the window, it's mounted below the window, you know, because it's lined up with a window right here. So look over here in this area, and you can see that we have a gas fixture right here on that wall. So the plumber will come in, they'll put a gas fixture there. We have, see this HB, that's called a hose bib, that's your outdoor faucet. You have a vent, you have a 120 volt outlet, and you have a 220 volt outlet. So the 220 volt has 3 lines on it, so it's usually drawn like this. And then a lot of times you'll write 220 VAC or something like that for volts AC, alternating current. Now, the reason why you have gas and you have a 120 and you have a 220 and you have all this stuff is because in this area, there's going to be a stackable washer and dryer. So you've got to have gas and electricity and all these options for that stackable washer and dryer, including you've got to have this vent right there that goes through the wall. In this case, it's just venting right outside. Okay, because this is like a cabin that we're doing here, so it's not a real formal house. So I'm just pointing out some of the things you're going to see when you do your capstone project, and we'll be talking more about this. But let's come back to the dimensions. So we have 5 feet 10.5, 6 feet 1.5, and 12 feet. And if you add that all up, the width of the cabin is 24 feet 0 inches. Now, would we do that in a mechanical drawing where we have 3 dimensions and then we come in and we put another dimension in? We wouldn't do that, because if you have a tolerance on all these things, you couldn't have 24 feet. You would have come in here and put this in parentheses, right, and make it a reference dimension. But in architecture, because the tolerances are so loose, you know, because lumber is not very straight and all that, that, you know, if we're within plus or minus 1/8 of an inch, a 1/4 of an inch, you know, so we're not worried about tolerancing as nearly as much on an architectural plan. So we are allowed to have that 24 feet that gives us the whole thing right there. Okay. So let me go to the next slide. So whenever we dimension, as you can see right here, we've got our tick marks. We're dimensioning from the side of the frame wall to the side of a frame wall. So I want to show you something. What if you have a frame wall? So by that I mean, let's say it's, you know, it's made out of wood or whatever, and it's 4 inches thick. And then outside that, you have a masonry wall, like a brick ledge, or a white stone, like they do a lot here in Austin, right? So that there's stone outside of your masonry. So here's your masonry wall right here. Would it be okay to dimension from the edge of the stone over? And the answer is no, because the stone is too irregular. So what we would do, we would dimension from the framing, right? So we come inside that to put our dimensioning in. So don't dimension to the face of stone and brick generally when you're doing your dimensioning. Okay, so I'm going to skip ahead here. We also put dimensions on elevations, and this is a example of that thing you're going to draw if you decide to do the architectural capstone. You'll draw the front elevation and the side elevation of that cabin. So here was that porch we were looking at, and here's the windows and the doors, and here's the kitchen. Here's that window over the kitchen sink is right here. Okay, And but look right here, we've got a dimension of 1 foot 6 inches for that roof overhang. See how the roof overhangs the side of the wall? And we've got 1 foot 6 we're noting over here. We have a leader that says we have an 8-inch post, so there's a post at the corner of our porch. And then we have some other dimensions around here, mainly regarding roof overhangs, and like here we've got some dimensions for the height of our chimney and then the chimney cap. And then we have a dimension right here that locates from the edge of our house to the peak of the roof over there. Okay, so you will put dimensions on elevation drawings as well, but in our assignment that we're going to do today, all we're going to be doing is putting dimensions on the guest cottage. So I'm going to skip ahead now and show you a couple of things. When you're ready to put your dimensions on, the first dimension that we have, let's say this 3 feet 0 away from the house, when we print that, we want that to be at least 9/16 of an inch away from the house. And then our next row of dimensions, we want those to be 3/8 of an inch from the first row. But here's the problem we have. So imagine you're looking at your guest cottage and you're in model space. When you drew the guest cottage, you drew it 18 feet wide by 15 feet tall. We drew the guest cottage full size, just like we were out there on the site. Well, we're going to dimension in model space too. So if you imagine you were adding dimensions onto that full size floor plan, you wouldn't just measure 9/16 away from the edge of your floor plan, your actual foundation, and try to put a dimension. What we have to do is convert these, because what this is just what we want it to be when it's printed to scale. These are the minimum dimensions here. The conversion is actually this. The first dimension in model space, we're going to place at least 27 inches away from our house. Okay, so I want you to imagine that you're out there on the property and you're standing on the edge of the foundation, and you're going to put a dimension in, and you've got a can of spray paint. What you would do is measure at least 27 inches away from the house and then spray paint this dimension in right here. Okay, so it would be in the yard 27 inches away. When we scale it down to print it, that's where it comes out to be 9/16 of an inch. All right, then you would take your spray can and measure 18 inches with your tape measure, and you would put in this next one, and so this would be 18 inches right here. When you spray painted in your text, what you would do is you would write your text in 3 inches. You would spray paint your text 3 inches tall. So in the yard, the text would look like it was 3 inches tall. When you print it, it will come out about 1/8 of an inch tall, because you're scaling everything down. If we scale this down to 1/4 inch equals 1 foot, when we scale it, this is where all the scaling happens. So, like I said, that first line of dimensions, 27 inches away. There are architectural firms who have their own standard, because this is a minimum right here. I know a guy that the first dimension, he always puts 36 inches away. That's what their firm does, but we're going to go at least the 27 inches on ours. All right. So we'll see that here in just a little while on how all that happens. Now, there are some architectural dimensioning guidelines, and these are in your book, but they're also in Blackboard. And so I'll point those out to you in just a second when we get into Blackboard. And these are the guidelines right here. Okay, so I would say, does anybody have any questions? But y'all never have any questions, so not at least until after class. But you're welcome to ask anything or interrupt me as we get into it. Okay, what I'm going to do next is open up Autocad, and I'm going to show you what we're going to be doing. We're going to go back and open up our guest cottage, okay, that you drew in Chapter 4. Now, remember when you drew this, you hardly knew what you were doing. And so when you start putting dimensions on this, things may not be the right size, and you may have to go in and move windows or do something like that. So just be ready to make changes of this, because this was one of your first drawings when you made this drawing right here. The way you're going to start out with this is to make a dimension style. And so if you have your textbook, I'm going to tell you the page to go look at to start, and that page is 313. On page 313 are the dimensions that you used when you drew the guest cottage. And those are the dimensions that we need to get onto the guest cottage now. We don't need any extra dimensions, but we need every one of those. And so that's why using your yellow marker or whatever color you're using, and as you put a dimension in, highlight the dimension and make sure that you can account for every dimension that you have. All right. You can also see in there that there is a tub and there is a toilet and there is a vanity with a sink. And we're not going to add those now. We're going to add those in Chapter 9. I'm going to show you how to do all that stuff. And in Chapter 9, we're going to add those. And we're going to add a ceiling fan, and we're going to add switches and 120-volt outlets. So we're not going to print this until Chapter 9. So in Chapter 6, all we're going to do is put our dimensions on and save it. So everybody got that? You don't have to print this and submit it. Just save it with the dimensions once you get them. And it really doesn't take very long to dimension this. So you should be able to finish this up. And if you're not finished with everything in Chapter 5, probably have some extra time between now and Thursday to finish up Chapter 5 if you haven't submitted everything from Chapter 5. All right, so now look on page 314. And on 314 and 315, you're going to see all your dimension style settings. So there is a video in Blackboard that leads you through setting up all of your dimension style for this project. And so it's in those style settings you're going to set up your text height and your arrow or your tick marks instead of arrowheads. All those styles are going to be set up in the dimension style. So then when you turn to page 316, you actually get your step 1, step 2, and in step 3, it says to create a dimensions layer. So we're going to put these on the dimensions layer, and so you'll want to make a dimensions layer. And I think most of that's going to be covered in the video for how to put your dimensions on this. All right. So the workflow is going to be to create a dimension style, to create a layer named dimensions, make it current, and then start putting your dimensions on. And those should go pretty fast because there's not that many dimensions on this project. And I'm going to show you a little bit about how to do that, and then I'm going to turn you loose to work on it on your own. So I'm going to click on, here's my dimension toolbar, and right down there at the bottom, I have my dimension style button. If for some reason you don't have your dimension toolbar open, you might want to get it open, but you can also come up here to the annotation panel that you have right here, and there, right next to the word annotation, there's a down arrow. And by clicking right there, it will open up your dimension style manager. The same thing would happen if you pick right down here on this guy. Okay, so let's see if I can project this. All right, so what you're going to do is you're going to have the standard dimension style right there. So you'll pick on the new tab, and when you pick on new, it's going to take the settings that are in your standard style, and right here, your new style is going to be called Arc 24 for architecture, and I'll show you why the 24 in just a second. So Arc 24, and then you would press continue. Now remember, this is all going to be in the video. So instead of picking continue, I've already made arc 24, so I'm going to pick on arc 24 and pick modify and just show you some of the settings in the arc 24. So the first one, if you look on page 314, the first tab it shows you to open is primary units right here. And it says that your unit format should be set to architecture. That's what gives you feet and inches on your dimensions. And then it says precision. And if you remember precision, this is like when it's going to start rounding. And so what it says in your book there is to set your precision to 1/16 of an inch. So you could just pick on this down arrow right there and go right here and pick 1/16 of an inch for your precision for the arc 24 dimension style. And then any other settings that are on that tab you would set. Okay. Then you're going to go to the symbols and arrows tab, which is the next box open on page 314. And here's where you want to choose architectural tick. So those are those slashes that you see right there instead of arrowheads. So if you pick on the down arrow, you can see all the options that you have. And what we want you to choose is architectural tick mark. And you want it for your first dimension and your second dimension. So you want first and second should both be architectural tick. And then if you have a leader, we want an arrowhead on the leaders. And we're going to set the leader arrow size to 3/16 of an inch. Now, if you don't see fractions here, that would be a good indicator that under primary units, you don't have architectural units set. So you'd want to make sure. And then we're going to have our line set, and center marks will be 1/16. And then at the top of page 315, we get into the lines tool. And this is where we have our offset from origin right over here. That's the visible gap that you have. Extend beyond dimension lines. That's how far the line extends beyond your tick mark. That's going to be 3/16. And so you've got all these things that you're going to make sure that you set. And that's at the top of page 315. Then you're going to pick on text. And you want to set your text style to standard. Your text height to 1/8 of an inch. And then here, text placement should be above the dimension line. So that's another difference between mechanical dimensioning and architectural. In mechanical, we break the dimension line. In architecture, we write above the dimension line. So this is all on the text. And as I said, if you're not getting all this, there is a video on creating the dimension styles that you can just watch that and set your dimension style up. And we're going to center the text, and the text should read from left to right. And the other thing we want is right here. It says aligned with dimension line. So what that does when you select align with dimension line is this. Your dimensions are going to face the bottom of your sheet, and they're going to face the right side of your sheet if they're vertical dimensions, just like this text right here is facing to the right. So the text is being aligned with the dimension line. And we didn't do that in mechanical. All your dimensions face the bottom of the sheet. So this is a little bit different too, right there. Okay, so I want to point something out right here on standard text style. I'm gonna cancel out of this and close this. When you were drawing this originally, we told you to use the Stylus BT text style, but you were a newcomer and you may not have gotten that set right. So just as a reminder, you would go up to Format, and you would go to Text Style, and when this box opens up, here's your text style standard. We don't want to change that. We want that to be standard. But the font name, which we were setting to Arial when we were doing mechanical, we're going to set to Stylus BT. It should already be set. Stylus BT looks like this right down here. It looks like architectural freehand lettering. All right. So it doesn't look like Arial does, and you don't need to mess with anything else. Although, you know, when I was showing you guys how to do freehand lettering, one of the things I suggested is to make your letters a little bit wider. If you wanted your letters to be a little bit wider, you could type right here on your width factor, you could go 1.5, for example, and did you see how much wider it made that example down there? Which makes it look a little more like a good architectural style. I'm not saying you need to do that. I'm just saying these are the characteristics of the standard style right over here. Anything you set in there. Okay, so I'm going to click real quick and get back in. And so the last thing we want to look at is the fit tab on this guy. So we pick on fit, and we're going to have either text or arrows beside the dimension line. And remember I said the name of this text style is, or this dimension style is called Arc 24. Here's where the 24 comes in. You see right here, you're going to set 24 in this box right there. Now you're probably wondering, why are we setting that to 24? Okay, so here's the explanation. A minute ago, when we were looking at our text height, we set our text height to 1/8 of an inch. But we have to imagine that we're putting that text in out there on the job site with our spray can. And obviously, 1/8 of an inch would be like the length of an ant, right? It would be invisible. So we really can't have text on our job site when we're putting our dimensions in at 1/8 of an inch. So when we go to our Fit tab and we put a number in right here, it takes all of our dimension settings and it multiplies it times that number. So what's going to happen is our 1/8 inch text is going to be 24 times bigger. And what that will result, if you take 1/8 of an inch and you multiply it times 24, it's going to be 3 inches tall. So that's where we're getting our 3-inch text height in model space. Remember though, we're going to print it to an 8.5 by 11 sheet of paper in layout, and that's where it's going to get shrunken down to 1/4 inch equals 1 foot, and that's where it will be 1/8 of an inch. But in model space, it's going to be 24 times 1/8, and every other setting is going to be multiplied times 24. And that's why we named this Arc 24, because it's an architectural style, and all our values are being multiplied times 24. After you get that, you want to pick Arc 24 and pick Set Current, like that, and then you can close. All right. Now, when you're ready to start dimensioning, let's look at the top right across here, and then look. I'm looking on page 313 at those dimensions. The first dimension is to the center of this window, and it says that's 6 feet 6. And then I have a dimension of 4 feet 2, and then I have a dimension of 7 feet 4. All right. And remember I said I want to put my first dimension 27 inches away from the edge of the house. So here's what I'm going to suggest that you do, and this will be in the video. Zoom in on the house and pick on that line right there. You want to offset that line right there 27 inches. And then you want to put your dimension right on top of that. So you can use your offset command up here when it asks you for your distance, type 27 and press enter. And be careful you don't get your hatch pattern. Pick that and just pick above it. So there's where I'm going to place my first row of dimensions. And what I do is I select on that and I make it longer. I just drag it out a little bit like that. That makes it easier to erase later because it's just a construction. And then I do another offset, and this one I set to 18 inches. And one thing I want to point out in AutoCAD is you don't have to put inch marks in. You can just type 18 and press enter. But you have to put foot marks in if you're typing in a value that has feet. So I'm going to type 18. I don't have to put inch marks in. Press enter, and then pick that line that I offset at 27 and pick above it. So I've got my 27 inches and I've got my 18. And it would actually have been a good idea to have gone around and done that on all four sides of the house while I was with my 24-inch offset and while I was with my 18. That would just speed things up. All right, so now I have dimensions set as my current layer, and I'm going to use the linear dimension tool to place the first dimension. And so that's right up here at the top of my dimension toolbar, or I can come over here and pick linear under annotation, either one, and it says specify the first extension line origin. That would be at this corner right there. Then it says specify the second extension line. That would be at the midpoint of that window right there, because we're going to dimension to the center of that window. And then we're going to move right up here, and when I get to that line, I'm going to snap. I'm just going to pick right there. So 6 feet 6, I did that with a linear dimension. All right, now I'm going to show you how fast this is going to go, because my next dimension is going to be a continuous dimension. See this option right here? And when you pick on continue, it picks up where your last dimension ended. And so now what I want to do is I want to come and I want to pick at this corner right there of that wall. And pick, and it puts in 4 feet 2. And then I'm just going to move right over here and pick on that endpoint right there, and then press escape. So there's my first row of dimensions. The 6 feet 6 was placed using linear, and then I picked on continue, and I put the 4 feet 2 and the 7 feet 4. So I went really fast. So some of you right now are saying, this is so much easier than mechanical dimensioning. I'm switching my major. I'm an architectural major now. But the thing is, your drawings, your floor plans are going to get more and more complicated, and this eventually gets to be a challenge, I promise you. All right, so now what I want, if I look on page 313, is I need the overall length. So I'm going to pick on linear again. And this time I'm going to pick right where that tick mark comes together. Right there, I'm going to pick there. I'm going to go to the one at the opposite end and pick. And I'm going to move up and I'm going to snap onto my line that I offset 18 inches out. And there's my first 2 lines. And then I'm going to pick right here and delete those, because those were just construction lines. That's a beautiful thing. I've got all those on there. I could take my marker, my yellow marker, and highlight all those, because I know I've got those now. All right, so those are pretty easy right there. Those are pretty easy. Okay, now let's come back here and let's look at one that's a little more complicated. I said you have to dimension to the center point of this door. And the problem is that when you try to snap to the center of the door, because the way we drew the door, it's not going to find the center of the door. So how are you going to do that? So I'm going to show you how. So we're going to start again by doing an offset and type 27 and press enter. And we're going to take this line right here and offset it 27 inches down below. And then we're going to pick it and drag it out. And like I said, what I would do is just press enter and stay. Since you're in the offset command anyway, you could come in here and pick this and, oh, I got it on the wrong side. Put it over there. Let me get rid of that one. And I could do it again, press enter, and pick here. I want to get that line actually. Come on, offset, press enter. And so those would be where I would put the first dimensions on those sides over there. But the next thing I'm going to do is do another offset and set it to 18 and press enter. And I'm going to pick here and I'm going to go below that. So I'm going to offset that 18 inches because my second line of dimensions will go there. All right. So I'm going to place a linear dimension from this corner to the center of that door. And this is tricky. So this is going to be worth tuning in today to learn this. This is ninja drafter stuff right here, okay? I don't show this to everybody. Only my favorite students get this. All right, okay, so here it goes. You pick on linear, and it says specify the first extension line. Snap to that corner right there. Now you come in here and you're like, well, where's the center of that door? It finds the center line, but that's clearly not the center of that door. Here's what you do. Hold down your shift key and right click your mouse. And then pick mid between 2 points. You're going to snap to the middle between 2 points. So I went shift, right click, and then I'm going to pick mid between 2 points. This is in the video, by the way. And then here's what I'm going to do. My 2 points are going to be the hinge jamb, and that, remember, this is where my hinge is, so I'm going to pick right there where the hinge jamb is for that door. I'm going to pick there, and then it says, where's your second pick point? I'm going to pick right here at the strike jamb. I'm going to pick right there. And look what Autocad did. It found the midpoint between those 2 points. So I'm going to show you that one more time. You pick on your linear dimension tool and snap to this corner right there, and then hold down shift and right click your mouse. Go pick mid between 2 points. That's the ninja stuff right there. And then you're going to go pick at the hinge jamb, and you're going to pick at the strike jamb, and you're going to move right down here and put it right on that 27-inch thing you've got right there. Okay, so that offset with 27 inches. Now you're going to switch over to continue, because this is going to be easy now. You pick on continue, and it starts measuring from the center of the door, and you can snap to the midpoint of that window, to the midpoint of this window, to the midpoint of that window, and to the end point, and then press escape. Look how easy that is. Now, the reason we can snap to the midpoint of these windows is, if you remember when you drew that window, you used the rectangle command, and it said to draw a rectangle that was 36,4 and press enter. So we drew our windows 36 inches wide, and so it can find the midpoint of that front edge right there, and that's what it's doing. And then what you did, you drew from midpoint to midpoint here, and so that represents the glass inside the window, and then this is the window frame and everything right there. All right. Now, when you put that dimension in, what you may see, though, is, remember this A that you have right here with a circle? That is your window mark. When you placed your window mark, you didn't know there were going to be dimensions come in here. And so if your dimensions run through your window mark, you need to move the window mark away, okay? And the way to do that is to use your move command. So you pick on move, and it says select objects, pick the circle and the A and press enter. And then it'll say specify a base point. And the base point is like a handle. You could actually pick your base point out here in space, and then just move to your left and make sure that you're moving, orthogonally, that you want to go straight, and just move that away from your dimension and pick. So if you run your dimensions through all these window marks, I'm going to mark them all off with -1. All right. So now that you've got that first line placed, you just go back and do a linear and pick right here in the middle of that tick mark, pick there, go to the opposite side, pick there, and come down here and pick on the 18 inches. And that should say 18 feet 0, and then come in there and delete that out. And you'll need to add a note in here that says that your wall thicknesses are 4 inches. Otherwise, we would need to put a dimension on here saying 4 inches, but we can cover that by putting a note in here. The way to put the note in, I would pick on this. I would actually use multi-line text and draw a rectangle like that. And then when you look at your cursor right here, I want you to look right up here and see what your text height says that it is. And if you remember, we had 1/8 inch text over here multiplied times 24, and I said that would give us 3-inch text. So for this note, we need 3-inch text. So just imagine you're writing that note with your spray can 3 inches tall out in the grass by the house. So what you would do, you have your cursor blinking there, come right up here and pick right here and type 3 and press enter. And then you can type notes. Of course, you'll do it all caps, and 1, always number your notes, and then type what it is that you want right there, and then close the text editor. All right. Before I get off the air here, the last thing I want to just point out to you is that if you and I were talking about this drawing and we were both looking at it online, and I said, well, you need to put that dimension in, and I said, look at that 4 foot 2 inch dimension plan north. Plan north means that on your plan, it would be the north side of your plan. Okay, it just helps people find stuff. So you would say, okay, that window, the B window is plan north. So they would look up here on the north. You could say, look plan west and find the A window or something. And this would be plan south down here where I put these dimensions in. And this would be plan east. Okay, so just imagine the compass points. And so I've been, when we were designing the Highland campus phase 2, and we would have a bunch of architects in the room, and we had these gigantic D-size sheets, and we'd have somebody on the phone or something, and we'd be talking, okay, well, you look plan north, that's where we're talking about, or plan south. And so it just helps you get oriented on where things are. All right, so when you pick on the layout tab and you go in here, you're going to see your dimensions. And because when we print this, now we're not going to print it now, we're going to print it in chapter 9, we're going to print it to an 8.5 by 11 sheet, so it's got to get scaled down. And the scaling on it, if I pick on my viewport and I look right over here, it says 1/4 inch equals 1 foot, right down here in my scaling. So that's what we're going to scale this at, is 1/4 inch equals 1 foot. Now I want to remind you about these viewports. That is a viewport, and it's already in your prototype drawing, so you should have that, but I'm going to delete it. When you delete a viewport, you lose your ability to see into model space. And so if you ever lose your viewport, I just want to review you on this. You type Viewports, and as you start to type VOPORTS, you'll see the option to pick viewports. And then you can have 3 viewports or 2 viewports, but we're going to pick on a single viewport and pick OK. And at that point it says, where's the first corner of the viewport? Well, just come right up here outside your sheet of paper and pick, and then let go and come all the way over here and pick. And you'll be able to see back into model space again. Now, I'm still in paper space. It says paper right here, and I also have this triangular shaped UCS over here. But if I double click back in here, that puts me back in model space. And I would press F7 and turn my grid off, for one thing. And then I would hold down and I would kind of center, get that centered where I wanted it to be. And then I would come out here into the gray space and double click or go pick on model and turn it into paper. And now I'm back in paper space, so I could fill out my title block and everything, but my scale is not at 1/4 inch because I just put a new viewport in. So what I would do is pick on my viewport, highlight it, and then look right down here on the status bar and pick on that up arrow and go find my 1/4 inch equals 1 foot. Now when I pick on that, it's going to zoom in and it's going to go to 1/4 inch equals 1 foot. And the next thing I would do is I would pick on that viewport again, and I would move right over here, and you see that lock down here on your status bar. I would pick the lock, just pick on it, and it'll turn blue. And what that does is it locks your viewport. So when I zoom in and out, I can't mess up my scale. All right. So a few of you in doing the Chapter 5 projects somehow got your viewports erased, and I had to kind of help you with that, so I thought I would just cover that again with everybody. Okay. All right, so you don't have to print it now. We'll reopen it in Chapter 9 and add more stuff to it, so just save it when you're done. This assignment should be completed before Wednesday at 11 o'clock. And I think if you watch the video, it's probably going to take you an hour or less to do this project. Of course, I wouldn't wait to do it. I would go ahead and knock it out. But anyway, let me go back into here. Now, there's one, I realize there's another dimension I want to show you. You need a dimension to the center of this door right here. And so you're going to use your linear dimension. You're going to pick at that corner right there. And again, you want to do Shift, right click, mid between 2 points, and pick at the hinge jamb and at the strike jamb and put that guy in. So just keep that, that little trick in mind. So there you go. That is your assignment. So if anybody has any questions or anything while I'm changing my screen here, I'm going to go to Blackboard. Feel free to unmute. When you log into Blackboard, where you want to go is right down here to the Chapter 6 curriculum and pick on it. And there is a video on dimensioning basics. It's pretty much kind of what I talked about earlier today, so you probably don't have to watch that. Then there's also these PDFs, the quick reference for architectural dimensions, and then the guest cottage dimension style help sheet. But then what you want to do, it tells you, here's your assignment, project 6.1. Come down here and pick on this folder. And when you do, it will tell you what to do. Open the guest cottage, add a new layer named dimensions, assign a color, all this stuff. There's even a video on setting it up. But then right here in step 2, there is a video on creating an architectural dimension style. So if you need to watch that video, watch it. Otherwise, just follow the steps right here that are in your textbook. And then step 3 says add dimensions to the guest cottage. Watch this video. This is the video that will lead you through what I was showing you guys about doing your offsets and everything else. So that's where your video is. And at the bottom it says we will print this later, so you don't have to worry about printing it. That's it. So if you have any questions, feel free to ask or stick around. And I'll be on here till 12:40 today, and you can always email me. And as I said, if you haven't turned all the Chapter 5 projects in, keep working on them and get them in. They're really important that you get those finished, even while you're working on this thing right here. So that's it for today. I will see you guys on Wednesday at 11 o'clock. If you're leaving, let's see somebody's chat. Oh, and okay. So I'll stick around and answer questions if anybody has. Otherwise, have a great day, and I'll see you on Wednesday.
Check, Mike.
Yep, I can hear you.
Right. I got about 5 minutes before I just pass out. I'm so tired. So I had a question on the tool slot.